Okay, we will go now to a new chapter, which is stoichiometry. Stoichiometry, what we mean by stoichiometry, we will be doing chemical calculations. We will do what? We will do chemical calculations. We will calculate atoms, molecules, masses, percentage, reactants, products. All of these is under name what? Stoichiometry. Stoichiometry, it is mass relationships in chemical reactions. We will learn Avogadro's number and the mole. We will need to get calculations from balanced chemical equations, from formulas, and we need to know something which is limiting reactant. Okay. The mole. The mole, it is the SI unit for amount of substance. For chemists, we have our own unit, which is the number of moles. The number of moles, the mole, it comes from what? It tells me that carbon 12 has 12 grams. So these 12 grams are equivalent to what? 1 mole of carbon 12. 1 mole equals Avogadro's number of particles. If it is element, we say atoms. If it is compound, we say molecules. If it's ions, we say ions. And it has the number, a magic number, which is 6.02 multiplied by what? 10 to power 23. 10 to power 23. This is the Avogadro's number. Moles to Avogadro's number, multiply to number, multiply by Avogadro's. From number to moles, multiplied by the inverse of Avogadro's number. Numbers, atoms, go to moles, multiply by the inverse, all divide. Moles to atoms or molecules, multiply by what? By this number. How many atoms in 0.1 mole? Helium gas, okay? 0.12 mole, just multiply by Avogadro's number. How many moles of carbon in carbon atoms? Atoms to mole, multiply by what? The inverse of Avogadro's number. Molecules in 0.06 moles, multiply by the number of moles with what? With Avogadro's number, which is 6.02, 10 to power 2 is 3. This is the periodic table. This is our reference in chemistry for chemical calculations and for what? Chemical properties. Okay, now we will look at it for what? We will look at it for calculations. We will look at it for what? For calculations. So if you look at each atom in the periodic table, there is atomic mass and there is atomic number. Atomic mass, which is important in what? Which is important in chemical calculations. For properties of chromium, chemical properties, we will look at its atomic number. But here now, we will look at what? We will look at the atomic mass. What does that mean? 52. We can say chromium has 52 atomic mass unit, or we can say 52 gram per mole. Mole of what? Of a chromium atom. Okay? And you will find this for the elements in the periodic table. Each element has atomic mass. Each compound has molecular mass. Okay? Okay, let's have the glucose. Glucose is a compound. The compound has what? Chemical formula. Has what? Chemical formula. C6H12O6. What does that mean? One molecule of glucose consists of what? 6 carbon atoms, 12 hydrogen atoms, 6 O atoms. Or we can say 1 mole of glucose, 6 moles carbon, 12 moles hydrogen, 6 what? 6 this 0 should be removed, okay? 6 atoms, 6 atoms. Oh, okay, 12 H atoms and 6 O atoms. It's not 6 O atoms. Okay, carbon from periodic table 12. H1 O 16. In chemical calculations, we say gram per mole. Gram per mole. So, atomic mass for the atom and molar mass for the molecule. 6 multiplied by 12, 12 by multiplied by 1, 6 multiplied by 16, 180 gram per mole. So when we say glucose, C6H12O6, 180 gram per mole. Sometimes you need to calculate it from the elements in periodic table. Sometimes we give it to you, okay? We give it to you. He told me that you have 10 grams of glucose. Now I know the molar mass. I calculate it. What can I calculate? I can calculate the moles. The moles, mass over molar mass. I can calculate the molecules. I can calculate the molecules, okay? Moles multiplied by Avogadro's number. Okay, I can. From glucose, I can calculate carbon, hydrogen, and oxygen. Moles of carbon, moles of glucose, multiply by 6. You start from the beginning. Mass over molar mass, these are the moles of glucose. Multiply by 6, it is the moles of carbon. Okay. Mass of carbon, okay? One step, multiply by the moles, multiplied by the atomic mass. It means that 10 grams glucose contains 4 gram carbon. I can also say the percentage of carbon is glucose. 4 over 10 multiplied by 100, it will be 40%. It will be what? 40%. Okay. I can calculate atoms of carbon. Always I go to number of moles. I need atoms of carbon. What I need? I need to go the moles of carbon, which is mass over molar mass, multiplied by 6, multiplied by Avogadro's number. You see? From glucose, I can make calculations on what? I can make stoichiometric calculations in C6H12O6, which I can calculate moles and molecules. I can calculate also for carbon, moles carbon, atoms carbon, mass carbon, percentage of carbon. Okay. We can also make calculations for hydrogen. Okay. Get your calculator. Moles of hydrogen will be what? Mass glucose over 180. It will give me what? Moles of glucose. To go to hydrogen, I multiply by 12. Why? Because each glucose molecule contains 10 atoms of hydrogen. Okay, now I have moles of hydrogen. If I need atoms of hydrogen, multiply moles hydrogen by what? By Avogadro's number. If I need mass of hydrogen, multiply moles of hydrogen multiplied by its atomic mass, which is 1 gram per mole. Use your calculator. These are the numbers which you should get. Okay. Also, we can make calculations for oxygen. Moles of oxygen, they are the same as the moles of carbon. Why? O6C6. 1 mole of glucose contains 6 moles of carbon and what? and 6 moles of oxygen. So moles of carbon are equal to moles of what? Carbon and oxygen are the same. By the same thing, the number of atoms of carbon and the number of atoms of oxygen are the same. Why? Because I multiply the number of moles by what? Avogadro's number. But the masses are different. Why the masses are different? Because in carbon, I multiply the moles by 12. In oxygen, I multiply by what? By what? By 16. Okay? I want to check if I am correct. I have 10 grams glucose, which is grams of carbon plus grams of hydrogen plus grams of oxygen. If you sum them, they will give you what? If you are correct, they will give you 10 grams. They will give you 10 grams. So this is what we name it what? We name it from formula. Stoichiometry from formula. What does that mean? We can calculate elements from compound. Elements from compound. Another example, calcium phosphate. We need to calculate the first thing, its molar mass. It consists of what? 3 calcium atoms. 1 phosphorus? No. Phosphorus multiplied by 2. So 3 calcium, 2 phosphorus. 4 oxygen? No, not 4 oxygen. 8 oxygen. Okay. 3 calcium, 2 phosphorus, 8 O. Go to periodic table. Calcium 40, phosphorus 31, oxygen 16. So the molar mass of calcium phosphate, how much? 310 gram per mole. Aha, this is good, challenging question. Always you will find it in exams. How many nitrogen atoms in 10 milligram NH4NO3? We give you the molar mass of NH4NO3, okay, to save time. So, in calculations, the mass should be in grams. The mass should be what? In grams. If it's in milligrams, I have to change it to grams. Then continue. Milligrams, ammonium nitrate. Grams, ammonium nitrate. Always go to number of moles. Moles, ammonium nitrate. Then, how many nitrogen in ammonium nitrate? 1, 2. Then multiplied by, to go from moles to atom, multiply by Avogadro's number. I have 10 milligram. I need the milligram. I multiplied by 10 to minus 3. Now the answer is what? Grams. Divide by 80. It is moles. It is what? It is moles of what? Moles NH4NO3. I need moles of nitrogen. How many nitrogen I have? 2. Then multiplied by 2 over 1. Till now the answer is what? Moles of nitrogen. Goes to atoms, multiplied by Avogadro's number. Okay? Repeat the example. He tell you, you don't have 10 milligram, you have 10 microgram. If this is microgram here, this will not be 10 to minus 3, it will be 10 to minus 6. Do this practice question. The concept of the mole, the atoms, and the molar masses, atomic masses, and we can make calculations from formula.